All right, f function was 3x plus 8. And the g function they gave us was x minus 8 over 3. Your job was to tell if they were inverses. So you're doing f of g of x. Your goal is whatever you put in, you want to get back out. So you wanted to get x at the end of that. And then when you did g of f of x, you also wanted to get x back out. So that's your goal. So starting with f of g of x, whatever letter's closest to the x, that's what you pick up. So we're going to pick up that function, and you plug it into the f function. And it looks like this. So you have 3 times what's in parentheses. Fractions confuse people. So let's talk about what happens when you have a whole number in front of a fraction. So whole number, you can convert every whole number to a fraction by putting a 1 underneath it. So if that helps you, then I would recommend doing that. That makes it easier to see whether that 3 is on top or on bottom. Sometimes people multiply the top and bottom by 3. Sometimes they'll put that 3 on the bottom, and people aren't sure. So if you need to change your whole number to a fraction, that's easier to see. This 3 is in the numerator, that 3 is in the denominator, and they will cancel. So that's what we want that to do. We want that to cancel. Don't distribute. If you distribute the 3, you won't be able to tell that something will cancel. So when that happens, I'm left with, okay, so I'm right here. I just did 3 times x, and now I have to add 8 to that. No, move that. Scoot that. So now I have x minus 8 plus 8, and I get x back out. So right now I have that satisfied. F of g of x gave me x. Now I need to test to see if the other rule is satisfied. So g of f of x. So I got to pick up the f function this time because that's what's closest to the x. The f is 3x plus 8. So pick that up. Here's the g function. You're going to put that right there. 3x plus 8 goes right there. So I have 3x plus 8 minus 8 all over 3. Right now you can't cancel those 3's. I can't right now because you have, oh, I should gesture on here. Oh, that little, isn't that sassy, that little, woo! You have addition and subtraction binding all this stuff on top together. So I can't cancel those 3's. But I can do plus 8 and minus 8 cancel each other. So those cancel each other. Stop it. You get 3x over 3. Now I have no addition or subtraction, and those cancel. So the second condition has now been met. Everybody gets an x back out, so therefore they are inverses. Inverses, yes. So we have that. That's 3. Let's go ahead and go to number 4. Number 4. We won't do all of them, but I think these are good ones to do probably. 4x plus 9, that's f g. X minus 9 divided by 4. You're testing f of g of x. Let's do that first. Pick up the g function, plug it into the f function. It looks like this. 4 times x minus 9 over 4 plus 9. Because that f function says 4 times whatever x is plus 9. So we did that. 4 times this chunk plus 9. The 4's canceled. That one's on top. That one's on bottom. I know it's on top because it's a whole number, and that means it's 4 over 1. So you're left with x minus 9 plus 9, which is just x. So that one worked. G of f of x. Now we're going to go the other way. We're going to pick up that f function and plug it into the g function, right there where that x is. So we're going to plug in 4x plus 9 right there. So we have 4 times, nope, wrong way. We have 4x plus 9 minus 9 all over 4. I have plus addition, subtraction on top, so you can't cancel those 4's right now. But plus 9 and minus 9 do cancel. I'm left with just 4x over 4, and that gives me just x. So those are both inverses of each other as well, because I got x back out. It's now recording. Well, I don't think that before was the confusing stuff. I don't know. Minus 81 over 9. Now you have the same denominator, and you can combine those two. So I have 5x plus 25 minus 81 all over 9, and that's where that negative 56 came from. All over 9. And that's all you can do. You can't simplify anything else. But it didn't give me x, so it's not an inverse. So just to recap, I guess you can see most of it in there. Nothing canceled. I distributed that 5 just to the numerator because it's only in the numerator. Oh, that's not helpful in video. I distributed that 5 only to the numerator because that's the only location that it was. It's 1 times 9 on the bottom. That gave me 5x plus 25 over 9. And then we did this to get a common denominator because you have to when you're adding and subtracting. That put us here. And then 25 minus 81 is negative 56. So that's f of g. At that point, you don't need to do g of x, g of f, because you already know it's not that. But I'm happy to do it if that was tricky as well. Everybody good with that one? Did 6 do the same weird thing? Okay. Okay. All right, my guess is if you missed 5, you might have missed 6, and it was probably for that reason. I will say to you at this point, on your test Tuesday, if you get to this point and you see right here that they are not going to cancel, you do not have to complete. You can say not inverses and move on. There's nothing wrong with going that far, but you do have an hour to complete your test. So for time purposes, you can just go on. Tim, what do you got?
I'm just looking at that up there where you said that you looked at that and you see that they would cancel out.
Yeah. So what I noticed from is that this number is not going to cancel with that 9. And so that's what happened before is this number would always cancel. And then we were always able to cancel these, and I would just have x left. But I could tell right there, these are not going to cancel. And then I knew, like, when I had 25 on top, that was nothing was going to cancel. There are no their operations aren't opposite. You can eyeball that one in the beginning. This is a trick just like to double check your math. So if you doubt sometimes your algebra, you may be stronger logically. So I'm going to tell you this hint, if all else fails. Now you still will have to prove your answer. Math is about proving. It's not about spitting out the answer. It's about proving what it is. But when you look at this, it's about opposite operations. All inverses are. I have a minus 9. The opposite operation is plus 9. You do not have plus 9 here. Automatically, you know that's not an inverse. Same thing, you had times 5 here. You do not have times 5 here, so you know it's not an inverse. So that's a quick where you can go, well, I already know the answer. Now I just have to prove it. But let's say you're running out of time. Let's say you skipped that one on the test and you're running out of time, or you're getting very frustrated. Then it would be okay to say, based on the fact that I do not have opposite operations, you can write me a thing. I see that I have minus 9 in the top. I don't have plus 9 here. Then I'll accept that as a proof because it shows you have understanding of what an inverse is. So you can always kind of revert to logic if your algebra makes you nuts, which it will. It will. So step 1, we changed our f of x to y. Step 2, we switched directions or places with our x and y. And now your goal is to get that y all by itself. You have 2 things to get rid of, a cube and a 2. Cubing is the highest operator. Your exponents are your high operations. It's a high rank. So you would do this one first. Get rid of the 2, doing the opposite. Minus 2 to both sides. And then always write what you have. So now I have x minus 2 equals y cubed. Okay? And you may not have worked with cubes often. So the opposite, just like the opposite of squaring is square root, the opposite of cubing looks the same, but it's called a cube root. Same radical setup, only with a little 3 in there. That's cube root. And you have to do that to both sides. So your inverse would be cube root of x minus 2. Did we not graph? We didn't graph the cube root, did we? Oh, it's such a nice little graph. I'm sorry.
So the cube root is over of the whole entire answer?
The whole thing, yep. You got to do it to the whole side. Yeah, because you're doing the cube root of the right side. You have to do the cube root of the left side, so it doesn't matter what's over there, but yeah. The difference would be, and I don't want to confuse anybody, but the difference would be, Tim, because I think we've had one where it didn't go inside. And so that would be if, let's see, if I had, okay, yeah. If I had y plus 1 cubed equals x.
Yeah.
Okay, if you had that, then you would do cube root of both sides. And I would have cube root of just x equals y plus 1, because those would cancel. And then when you do the minus 1, that doesn't get to go inside.
That's like 19 and 20.
Okay, so
Is that like those? Okay.
Cube root of x minus 1.
So it would be cube root of x minus 1, yeah. So it would look like that, with the 1 on the outside.
Yeah, that's exactly what 19 and 20 is.
Okay, all right, good. Yeah. So whatever's over there, when it's time to do the cube root, the whole thing gets cube rooted. Sometimes it's just an x. Sometimes it might be a whole expression. But anything that comes after it does not get to go inside the radical. If cube root is unfamiliar or it's been a while, just so you know, a cube root, it's like square root. It's asking, what smaller root number out there can you multiply by itself 3 times that will give you 8 for an answer? 8 is the answer. You're looking for the number that you multiply 3 times together to get 8, and it's 2. Because 2 times 2 is 4, times 2 is 8. So cube root of 8 would be 2. That's what your cube root is asking you. But that's the opposite of cubing, is cube root. So that would be this 18 would be that same issue. Yeah, you're right. Okay, so 19 and 20 is exactly what we did. So 18 would be the cube root of, and then x plus 1 is underneath that radical. 19, you have the cube root of just the x, and then minus 2 on the outside. 20, you have the cube root of just x with plus 1 on the outside.